So she wanted us to go over this is the video for the wiki, and this is file 1. I'm student 7, and the first one she wanted to do A, B, and C. So the first thing I had was naming the nomenclature, and this was the first structure she gave us for A. So first thing you want to do when you're doing the nomenclature is find the longest chain. And then after you find the longest chain, 2, you want to find the substituents. And after that, with that, you can name your structure depending how what it comes about with the different chains. So looking at this one, I realized the first thing you can do is the longest chain will be 1 here, 2 over here, 3 over here, then 4, then 5, and 6. So that's the longest chain. Now we have a substituent, which I'm going to do different color right here and right here. 1 at 2 and 1 at 3. So which means our structure is going to be 2, 3, dash, dimethyl. And because it was 6, it's going to be hexane for 6. Hexane. I ran out of space. But that will be that'll be for the first one she gave us for the first chain. So I'm going to erase that and go on to part B. So for part B, this is the structure she gave us. So we'll try to here, we have this with that, and this with that. So it's a structure she gave us for this one. So again, we're gonna do the same thing. We're gonna first find the longest chain, and looking at it, as you can see, starting from here, 1, 2, 3, and then we have, oh, sorry, there you go. Let me go back. That's 3 right here. 4, 5, 6, 7, 8, 9. So this tell me the mother chain is gonna be a no name. Now I can see I have a substituents at 4. I have one at 5, and I also have one at 3. Now at 4 it's an ethyl. So over here is an ethyl, and 3 and 5 are methyls. But knowing the alphabetical order, we know the ethyl has to go first. So this one will be 4 dash ethyl dash 3 5 dash dimethyl. And remember we said the mother name was nonane. It's gonna be, I'm gonna write it down here, nonane. And that'll be for that structure because you had substituents here, here, and here. Okay, and that'll be for that. Now I'm gonna go on to the third one she gave us. The third structure, which was, I'm gonna draw that right here. The third structure was so again, first thing we're gonna do is we want to find the longest chain. And the longest chain, as you can see, is this one is pretty straightforward. You can go straight on this chain. So 1, 2, 3, 4, 5, 6, 7, 8. So a mother chain is gonna be an octane. And now we gotta find the substituents. So we have a methyl at 2, we have a methyl at 3, we have an ethyl at 4, and we have a methyl F5. So this tells, remember the alphabetical order. So this tells me it's going to be a 4 dash ethyl dash 2 comma 3 comma 5 dash trimethyl, because there's 3 methyl in there, trimethyl. And remember, said the mother name was 8, so it's going to be octane. And that was for that structure. Now I'm going on to the second part she wanted us to do, I believe, which was, 1 second. So it's the second part question for Wiki 2, actually. She wanted me to explain for Wiki 2, number 2, I think it was 2C, if I'm not mistaken. Yeah, 2C. So it said, for each of the following, draw the best, most stable, and worst least stable Newman projection relative to the new bond indicated in each question. So for C, they gave us a 2-methyl butane. C, and they want us to look at the C2C3 bond. Remember, we're doing the Newman projection because we're trying to find the most stable and the least stable. So first, we want to draw out the structure. So butane is 4. So 1, 2, 3, 4. Now it says 2-methyl. So 1, 2, 3, 4. And then you have, it says 2-methyl. So it's going to be here. So it's going to be right there. So now, after we draw our structure, we know what we're looking for. So now we're going to draw a Newman projection, because remember, we're looking for C2 and C3 bond. So first, you want to draw the C2 bond. So you want to draw the Newman projection first. So I'm going to draw it in a different color. So black is going to be my C3 bond. C3. And I'll do red as my C2 bond. So first, we're looking at C2, and I can already see it has a methyl right here, because it says 2-methyl, of course. So C2 is going to be here. I'm going to draw structure here, here. So C2 has a methyl, so it's going to be CH3. That's the obvious one. Now also, you got to remember, it's connected to 1 over here. So that's going to give me another CH3. And then, last but not least, the hydrogen. Because remember, carbons has to be connected by 4. It wants to be to complete the octet. So next, we're going to do C3 in black. C3, which is right here. We already know, since it only has 2 bonds, 1 here and 1 here, which means it's going to have 2 hydrogen, because it needs carbons connect with 4. So it's going to have a hydrogen here and a hydrogen here. But we'll draw a Newman projection. So we can draw it anywhere. So we're going to say, okay, it has a hydrogen, 1. It has another hydrogen, 2. Cool. Now, we also realize it has a methyl. Because remember, it's connected to the, it's also going to the bottom, going to the 4. So you can draw it down here if you want. So you're going to have CH3. And then that would be, there you go. And then that would be your original structure. Now, it wants you to find C2 and C3 bond. It wants you to find the least stable and the most stable. So when something's more stable, you want it out staggered. Like this right here is stable. It's staggered. It's spaced out. When it's eclipsed, it's not stable. It's compact together. So these methyls right here are too close to each other right now. Even though it's kind of it's stable, but it's still kind of too close to each other. It could be worse. So I'm gonna show you when it's not stable, it will come out like this. So you will have this. You have an eclipse. So you have CH3. You have H. the CH3. And then now you're gonna have the hydrogen from right here is gonna come closer to this one now. And you got the other hydrogen from the other one from this side is gonna come closer to CH3. And then the CH3 you had down here, oh, sorry, I made a mistake. Sorry, this hydrogen is gonna go closer to CH3. It depends on how you draw it. So you're gonna have closer, and the CH3 at the bottom is gonna come really close to the CH3, basically on top of it. So CH3. So now they're too close again, too compact compared to the other one. So this will be eclipse, and it will be the worst stable. So you can have different Newman projection by different degrees and angles, from 0 to 300 and so on. But with 2-methylbutane, the hydrogen and the methyl just rotate around from eclipse to stable, eclipse to stable, eclipse to stable. And I was able to know that because one of the questions she asked on there also, I had to do a diagram of how the different angles, and I was able to see that. But when they are staggered on top of each other, it's eclipse, basically being stuffed somewhere. They're like all compact together, basically. So it's not gonna be stable. When you have freedom in space, you're more stable. When you have more freedom, each atom has its own little space compared to the eclipse one. So that was for that question. Next, she also wanted me to work on number 4. Number 4 on the Wiki 2, which I'm going to draw right here. So give me a second. So number 4, she gave us it was to name the functional group, and let me draw it on here real quick so you guys can see. So I had a OHC connected to a that's chlorine right here. So this was the functional group she gave me. So when you have to name the different type of functional groups within a structure she gives you guys, within a molecule. So first thing, going from left to right, first thing I realized the OHC, which is right here. I'm gonna do a different color for you guys, which is right here. So that will be an aldehyde. That'll be an aldehyde. So I spelled that wrong. There you go. Next, I see the ring. So this one right here will be an arene. At the bottom, you have a ketone. Next, over here, this is a alkyl aldehyde. So it's kind of hard to write with this pen. But so from this structure group, this is basically what you could get from that one, what you named. There wasn't really much others. Now, I'm not sure about this one here. So if anybody can, if it's actually has its own function, I'm not sure the name. Somebody can put it in the comment. That would be great. But that was the one she gave me. She wanted us to work on. Now, I was going to give you guys an example because it's kind of hard at first, but those are the ones she wanted me to show you guys. So I'm showing you so you can get the understanding of it. But I'm gonna give one more example so you guys can get a better understanding. So okay, so another one she gave us was, it had NC connected to a Sorry, these these look a horrible drawing, but I hope you guys get the gist of it. What I'm drawing. Connected to HN, which then connects to a double bond oxygen. Right here. Okay, so this is what she gave us. So again, starting from left to right, hope you guys get a little familiar from the previous one. So this one right here will be an arene. At the bottom, ketone. Up top right here, we have an alcohol. Sorry, I spelled that wrong. Oh, so okay, this writing's not right, but this will be an alcohol right here. That'll be the alcohol. This structure is the amide. This right here with the double bond will be an alkene. That one's pretty easy. And then you have a triple bond at the end, and that'll be an alkyne. Sorry, I ran out of space to write. Now, I don't know if she wants to count this one, but this right here is just one. It's just a methyl. Now, I don't know if she would want you guys to name it, but it's good to just have, just as in you're aware. So that'd be an arene. Now, this one would not be an arene because it does not have the bonds inside. So I hope you guys understand that. But that was just an extra example I was giving you guys so you guys can see different ways to name it.